Hello, everybody. So here's quiz one. I give you some time to look up over your solutions to quiz one or the comments, and I just want to do a shout out. Now, this is focused only on period two. Next time we have a shout out, for a quiz, we'll do period four and then period five. So we will rotate through. But let's look at question one. First of all, here's a question. Find and tell me, think through how you would evaluate this. This is Kyle. Good job, Kyle. First, finding the tangent 11 pi over 4, which is the same as the tangent of 3 pi over 4. That's correct. They are coterminal, which is and so the tangent of 3 pi over 4 is -1. So the tangent of 11 pi over 4 is -1. And -2 times -1 is 2. Yes, Kyle. Another one, Miss Flynn, is this one I like as well. More explanation, which I really appreciate. 8 pi over 4 is one full circle. That's correct. Thank you for putting that. Coterminal. Thank you. But thank you for putting that. And you multiply and you get that +2. That's great. And then McManus, Anna. I think this is my favorite one, but they're all close to number one. So first, evaluate this. You're absolutely right. First, evaluate this. And she notices that that's 3 pi over 4 plus a whole circle. So therefore, if you rotate around a whole circle, you have the same trig values. So tangent of 3 pi over 4 is -1. And she tells me how she found that, which is great. These are the x, this is the y, this is the x. You divide them because that's what tangent is. You get -1. That's excellent. So for slide one, very good. For slide two, we see Gabby again. And this is a great explanation. First, find the sine inverse of this. So she is saying that two angles have a sine of this. We know that she knows that many angles have this sine, but two angles within one full revolution of one circle. Pi over 3 and 2 pi over 3 are those two angles, but sine inverse will only accept angles in this range, or this is the range of sine inverse. And so in this range, pi over 3 is the 1. And then multiply 2 by pi over 3 to get 2 pi over 3. And then finally take the cosine of that. The cosine of 2 pi over 3 is -1. That's awesome, Gabby. Another one was Mr. Hoffman. And he said essentially the same thing. Within this particular range, it's pi over 3. You multiply by 2, you get 2 pi over 3. Very good, Justin. And who else we have? Swidarski. Yeah, awesome. For slide 3 is we are starting with Gabby again. Come on. Find, evaluate, which means find the value. So take this times this. And 7 pi over 6 is a special angle. Correct. And it has a sine of -1/2. That's correct. To make -pi over 3 easier, find something that's coterminal. So just add 2 pi, which is the same thing as 6 pi over 3. That's awesome. If you add 6 pi over 3 to this, you get 5 pi over 3. So really find the cotangent of 5 pi over 3, which is -√3 over 3. And you multiply and you get this as a correct answer. That's awesome. Another one was Miss Anna. Great. This is very similar explanation. Naomi. Noticing that the cotangent of theta is 1 over tangent of theta. Well, the tangent of -pi over 3 is this. So the cotangent is 1 over this, which is what she wrote right here, which is the same thing as this. She knows sine. This looks like a student who knows her unit circle. You multiply these two numbers, you get this. Very good, Naomi. And then Mr. Hoffman says something pretty similar. Slide 4. Well, for Naomi, so let's see here. 5 - 2 is is this ordered pair right here. This is called the reference angle. Reference angle is adjacent to the x-axis and the terminal side. So once we know the reference angle, see how she rotated the triangle correctly? This is the angle that's in question, and the opposite would be the -2 part, and that's how it's written here. 5 is the other leg. Pythagorean theorem discovers that the hypotenuse is rad 29. You know all three sides. Here's your angle, so the sine of this is opposite over hypotenuse, which she wrote right here. And notice correctly having the domain. Don't just say sine is -2 over rad 29. Sine of theta is -2 over rad 29. And then rationalize the denominator to get this. And Hoffman did it similarly. So, yep, awesome. At this point, I think I'm just going to just show students that weren't repeated. So let's see, Caroline Croft. This is great. So which one of these two is bigger? Well, this is awesome. 362 is indeed just past a whole circle. And so the sign of that would be just barely into the positives. It's above 0, but not much. So this is a positive number, but pretty small. 15 pi over 8 is almost a whole circle. That's correct. 16 pi over 8 would be a whole circle. So 15 pi over 8 is just 1 pi over 8 away. It's almost a whole circle. And that makes the cosine value is a positive number that's close to 1. So you got a positive number that's close to 1 and a positive number that's close to 0. Well, the number that's close to 1 would be bigger than the one close to 0. That's the justification. Let's see here. We got Mark Swidarski. And great explanation right here. Cosine is very close to 1. Sine is close to 0. So the cosine of this value would be bigger than the sine of this value. And Mark is again there. I'm not sure. I accidentally took 2 snapshots. I guess I was so excited. Slide 7. Mr. Squirbles. There are two explanations here that you need to know. A unit circle explanation and a triangle explanation. John did the triangle route, which is great. If you think of theta in a right triangle, 14 would have to be the hypotenuse, which is what he is saying, because the sine is opposite over hypotenuse. And the opposite would be 15. And in right triangles, the hypotenuse is always the longest side. So that is a great explanation. This is total nonsense. In a right triangle is good enough to justify it, because sine is opposite over hypotenuse, and that means the hypotenuse is 14, and the opposite is 15. How could the opposite be bigger than the hypotenuse? So that was John's argument. That's great. Mark's argument is equally good. It's just using the unit circle. The unit circle tells us that the sine value is the y value, and the biggest the y value can be on the unit circle is 1. And 15 over 14 is just bigger than 1. It's greater than 1. So because of the unit circle, it's nonsense. Hoffman gave a great answer, I'm sure, but we're going to do Caitlin's explanation here. What quadrant am I in? Sine is greater than 0. That means it's either in 1 or 2, because sine is y. It's either in 1 or 2. And sine times cosine is a negative, which means one of the two is a negative. That's great. One of these two is a negative and one is a positive. That's the only way you can multiply two things and get a negative, which would be cosine. So in other words, cosine would have to be negative since we know sine is positive. So you've got a cosine that's negative and a sine that's positive. That means you're in quadrant 2. Very good. Jordan, pray. Love this one. Which quadrant is theta in? So first, cotangent is negative, which means you're in quadrants 2 or 4. And cosecant times tangent. Well, let's see. In order for cosecant tan, they have to both be positive. Okay, for that product to be positive, they either are both positive or they're both negative. Since cotangent is negative, tangent is negative. And for something times something to be a positive, and one of those somethings is a negative, this also has to be negative. Cosecant has to be negative. And if cosecant is negative, that means sine is negative. And if sine's negative, y is negative, which means you're down there. You're below the x-axis, so you're in quadrant 4. And that is the entire quiz.